All right. So today we are going to solve a very popular DSA problem called relative sorting according to another array, right? So in this question, we are given two arrays, right? A1 and A2. And our goal is to basically sort A1 such that the order of all the elements which are also present in A2 should match their order in A2. So let's take this example to understand this better. So this is my input, right? A1 and A2, and this is the expected output, right? So now if you see over here in A2, 2 comes in the first position, right? Which would mean that all the 2's in my A1 will actually come first, right? Before any other number. And that is what is happening over here. All the 2's are actually coming first, right? And then if you see in the second position, I have 1 in my A2, which would mean that all the 1's in my A1 would then come after 2, right? So that is what is happening over here again, right? Then I have 8 in my A2, right? Which would again mean that all the 8's in my A1 would come next, right? And then finally I have 3 over here in A2, which would mean that all the 3's in my A1, if present, right, should come after 8 next, right? And that is exactly what is happening over here, right? And then finally what they are saying is that any element which is not present in A2 should appear at the end of A1 in the increasing order, right? So after doing this matching and then sorting these elements according to A2, what we will see is that whichever elements are actually left over, we will just append them at the end of the output, right? And we will just sort them in the increasing order. So that's what we have to do. And finally, this will be our output, right? That we will be returning. So that's the entire question. And also they are giving one more note over here that if the elements are at all repeated in the second array, that is in A2, we need to consider only their first occurrence. So for example, if 2 was also coming after 1 over here, right, then we would have considered only the first occurrence of 2, which is at index 0, right, while comparing and sorting A1 elements, right? So that is another thing that we need to keep in our mind, right? So that's it. Now maybe you can just pause this particular video and try to think of a solution. And once you're done, you can just come back and check the solution here. Okay, so now to solve this particular question, see, first of all, we need to understand that we actually have to sort A1, right? But then the sorting logic will be a little custom over here, right? We don't have to go with the regular sorting logic. Instead, we have to actually define a custom logic, which would actually compare all the elements over here in A1 with A2, right? And whichever element comes first in A2 should come first in my output, right? So that's the logic actually I need to translate and give to my sorting function. So first of all, what I will do is I will begin by building a hash map from A2, right? And this hash map will basically help us to assign a priority or a rank basically to each element from A2 based on its position, right? So for example, based on our A2, our hash map will have 2 at the first index, that will be index 0, 1 at index 1, 8 at index 2, and 3 at index 3, right? So now we have each element in my A2 present in my hash map now with their respective indexes, right? And this will actually help us to quickly look up every element in my A1 and then see which one is coming first. And now next what we will do is we will actually define that custom comparator now, or that custom comparison function that we were talking about, which will help us to guide our sorting, right? And this comparator will actually take 2 elements at a time, and then it will decide which should come first from among those 2 based on certain rules, right? And we are now going to see what are those rules. So in case 1, if both the elements are actually present in A2, we will compare their priorities using the hash map of A2, right? That means whichever has a lower index in A2, that will come first in the sorted result. So for example, in A2, if y is coming first, that would mean that hash of y will be smaller than hash of x, and this particular quantity will become positive. And hence finally y will come before x, right, in my sorted result, right? But consider if x is coming before y in my A2, right? That would mean that this particular quantity will now become negative and my sorting order will now get reversed, right? And now x will come before y, right? And that's the reason why we are taking this difference, right? Now let's see the second case, right? In the second case, we are saying that only x is present in my hash map of A2 and y is not present, right? That means x is present in my A2 but y is not present, right? In that case, I want x to come first and y to come after that, right? So in that case, I will just return -1 over here. I will return a negative quantity to basically reverse the original order and place X before Y, right? But for example, in the other case, if Y is in the hash map, but X is not present, then Y should come first and X should come after that. And then I will just return a positive quantity to keep the sorting order as is. So that's what we are doing over here in case 2. Now if you see case 3, if neither of the two elements exist in A2, we will fall back to the default ascending order comparison, right? So again, if you check this, if for example Y is smaller than X, then this particular quantity will be positive and Y will appear before X, right? Which is expected because we have to sort in the increasing order for whichever elements are not present in my hash map in the A2 array, right? But for example, if X is lesser than Y, then this quantity will become negative, right? And the order will be reversed and X will now come before Y, right? So that's how it will help us to actually sort these two numbers or any two given numbers at a time in the increasing order, right? And now in this way, our custom sort will be applied on A1, right? And each pair of the values will be compared using the comparator that we just defined, right? And this comparator function we will be passing as a key in our sorting logic, right? In our sort function, we can pass this custom comparison function as the key, right? And now maybe let's see some sample comparisons, how the compare function will be actually handling, these sample inputs. So for example, if I get 2 and 1, then both 2 and 1 are present in A2, right? But then 2 is coming first because 2 has a smaller index than 1 in the hash map of A2, right? So then 2 will come first in my final output, right? And that is expected. Now when we are comparing 5 and 7, they both are actually not present in A2, and so they will be following the normal increasing order, and hence 5 will be coming before 7, right? And now 8 and 3, again both are present in my hash map, but 8 comes before 3 in my A2 because it has a smaller index, and so 8 will come first in my final output as well. So that's how the comparator function will actually take care of two numbers at a time and then compare them and then sort them relatively, right? And then it will do it for all the pairs that it is getting, and finally the entire list will be sorted based on this particular logic, right? And finally, after we have sorted the input array A1, this is the output that we will be having, right? And this is what we saw in the expected output also, that all the numbers which are actually present in A2 will be coming first and they will be sorted based on the order that they follow in A2, right? So that's what is happening over here. And then finally, whichever elements are not present in A2 will be following a normal increasing order, and then they will be appended at the end of the final output. So that's the entire solution. That's the entire algorithm that we are going to follow. And now talking about the time and the space complexities. See, time complexity, first of all, we are actually creating a hash map, right, for A2, and that will take order of m time, where m is the size of A2, right? So that will be order of m time. And then what we are doing is that we are actually sorting A1 using a custom comparator function. So that sorting algorithm will take order of n log n, where n is the size of A1, right? So the overall time complexity will essentially be order of n log n over here. And now talking about the space complexity, since we are using an extra hash map over here to basically store all the elements of A2 in that hash map, I will be using order of m extra space, right? And then anyways, we are doing sorting in place for A1. So we are not using any extra space over there, right? So the space complexity over here will be order of m, and the time complexity will be order of n log n, right? So this is the entire solution. And now let's code this particular solution. All right, so now to start with, what we will need to do is we will first have to actually import an external utility which will actually help us to convert our comparison function that we are going to write into a key that can be actually passed into the sorted method of Python. So basically we cannot directly pass a comparison function, a custom comparison function, as a key in the Python sorted function. We need to actually use this external utility that we are going to import, right? So I'm going to import from functools this particular function, cmp to key. So that's what we are doing over here. Now what I will do is I will actually declare the function. I will call it as relative sort maybe, right? Like this. And this will accept A1, and also I will pass the length of A1, which is n, and this will also accept A2 and the length of A2, which is m, right? That's what we are doing over here. Now what I will do is I will just declare an empty hash map to store all the unique elements of A2. And now I will just loop over every element of A2 like this, right? And I will check if, the current element, which is given by a2 of I, is not already in hash map. Then I will just make its entry like this in the hash map, right? And I will just assign the current index as its value, right? So that's what we are doing over here, right? And now over here, I will declare my custom comparator function, right? And I can just name it as compare like this. And this will accept two inputs, x and y, like this, right? And now my first condition would be if x is in hash map, right? And y is also in hash map, right? In this particular case, I will be returning hash of x minus hash of y, like this, right? So that's what I'm saying. Now, if this is not the case, then I will check if y is in hash map, right? And of course, x is not in hash map, because if x was also there in the hash map, we would have got inside this particular condition only, right? So now we are saying if y is in the hash map but x is not, then I will just return 1 over here, a positive quantity, right? And in case, x is in hash map and y is not, then in that case, I will be reversing the order and I will be returning a negative quantity. So I will just return -1 over here, right? And in case both of them are not present in the hash map, then in that case, I just need to follow the normal increasing order, right? So I will just return x minus y over here, right? Now I will use the sorted function of Python, right? And I will sort this particular array, the given array. So it will be A1, right? A1 is what I need to sort. And the key will be basically CMP to key. And now over here, I will be passing my compare method like this, right? So this CMP to key, as we discussed before, also will help us to actually convert this custom comparator function into a valid key, which can be recognized by the sorted function, right? So that's what we are doing over here. And finally, what I can do is I can actually, since I'm doing this in place, this sorting, I can just return right over here, right? And this will be my final output, right? Now maybe we can quickly also test this particular solution, right? So what we can do is I can just declare two arrays over here, and let me just quickly copy it from here so that it's faster, like this. And my A2 will be basically 2, 1, 8 and 3, like this, right? So that's my A1 and A2. And now what I can do is I can just print the output of this relative sort function when called over these two arrays, right? A1, and the length of this A1 is 11, right? And also on A2, and the length of A2 is 4, right? And now let's see if we get the correct output or not, right? So I did a typo over here, and this should not be A2, this should be M, right? Like this. Okay, sorry about that. Now if I run this again, so we get the output correctly sorted in the desired sorting order, right? So that's it. This is the entire solution. And now I will see you in the next video. Thank you.